Hello students, and welcome to another video. Today we're going to be adding on to what we learned in the last video about determining the limiting reagent. Now we're going to use the limiting reagent to calculate the quantity of a product. So the question is what is the maximum number of grams of copper 1 sulfide that can be formed when 50.6 grams of copper react with 42.2 grams sulfur? So this is going to be very similar to the problem that we learned before. I just realized 2 in the last problem it's 4. So our numbers will be a little different, but for the most part, it'll be the same. And if you look down here, we're going to be converting our limiting reagent and comparing it to see how much of a product we can make. So let's do this. Let's balance the equation and then work our way through like we did in the previous video. So we have copper plus, there goes my lights. Hold on. All right, so we've got copper plus sulfur is going to form copper 1 sulfide. Now we have 2 coppers, we need 2. And in this problem, we have 50.6 grams, and we've got 42.2 grams of sulfur. And we want to know how much can we make when we have this much copper and this much sulfur. All right, so first step we need to do is convert our grams into moles. Okay, we need to calculate the limiting reagent from them, okay? So what we're gonna do is 50.6 grams of Cu. We're gonna divide that from 63.55 grams of copper. Okay, this is from the previous video, okay? We found the molar mass. I'm just rolling through it with you, okay? So we have 1 mole of Cu, and the next one is 42.2 grams of S. And we're going to convert that into moles. 1 mole of S is going to be equal to 32.07 grams of sulfur. Now our grams of sulfur cancel, our grams of copper cancel, and now we can calculate the moles of each, okay? I did this pretty quickly. In the last video, I went through it all with you. I'm just getting to where we want to get in this video, okay? So we've got 50.6 divided by 63.55, which is equal to 0.8 moles. All right, and then we're gonna do 42.2 divided by 32.07, which is gonna be 1.32. We'll just keep it basically the same amounts, okay? Now, we gotta compare to the mole ratio. And in the last example, I used copper as our example we pulled from, but this time I'm going to use this example, okay? So if I were to max out and use all the sulfur, how much copper would I need? Okay, so let's do this. So we have 1.32 moles, and actually this is sulfur and this is copper. Let me clarify those. So 1.32 moles of sulfur, and we're going to compare it to the mole ratio above. So for every 1 sulfur, I have 2 coppers, okay? Remember, if I write it over here, I have 1 mole of sulfur to 2 coppers, okay? I'll just write 2, I'll say moles of coppers, okay? And we can write this either way, okay? And in this example, sulfur's on top, and I want to cancel sulfur, so I'm going to put it on the bottom. So I have 1 mole of sulfur to every 2 moles of copper. Okay, so if I cross out my moles, they cancel, and I have 1.32 times 2. Oh, sorry, I'm not showing you. 1.32 times 2. That is equal to 2.64. 2.64 moles of copper. And then if you can see here, if I were to max out all the sulfur, this is how much copper I would need. But how much do I have? I only have 0.8. So we can tell that copper is going to be our limiting reagent, because in order to use all the sulfur, I need this much copper, but I don't have that much. So sulfur is going to be in excess, okay? So our limiting reagent is copper, okay? All right, you don't necessarily need to find out the difference, okay? If you're going to calculate how much excess you're going to have, you can do that. But in this problem, we want to find out how much of this copper 1 sulfide we can make. Okay, so now that we know that copper is our limiting reagent, oh, sorry, yeah, this is it. 50.6 grams of copper is our limiting reagent, so we're going to use that as our starting point. All right, so we're going to use the amount of moles that is present. So we have 0.80 moles of Cu. And we're going to directly compare that to the mole ratio of our product. Okay, so we have a reactant. So every 2 moles of copper, I need to create 1 mole of copper 1 sulfide. So if I come down here, it's going to be a 2 moles of Cu per every 1 mole of Cu2S, okay? And this is our mole ratio. Now, if I want to cancel it, I got to put copper on the bottom. So I'm going to put this one on the bottom and this one on top. So I've got 2 moles of Cu for every 1 mole of Cu2S, okay? My moles of copper cancel. Now, what it's asking for is it in grams, okay? We don't want the answer in moles, so we're going to go one more step, and we're going to have to convert our moles into grams. So we're going to have grams up here, and we'll have to find the molar mass of copper 2 sulfide. So for every 1 mole of copper 2 sulfide, how much would that weigh? So if we have 2 coppers, okay, I'm going to pull out my calculator, or my periodic table. So it's 63.55 times 2 plus 1 sulfur, which is 32.07. That's going to be equal to 159.17. Okay. It's going to be 159.17. So every 1 mole of Cu2S, I'm going to have 159.17 grams of Cu2S. Okay. So now all I got to do is multiply 0.8 with 159.17 and divide by 2. So if I have 0.8, I times that to 159.17. All right, and then I divide by 2, because that's the only number down here I'm going to divide by, because 2 times 1 is 2. And that gives me 63.67. 67 grams of Cu2S. So if I started out in the beginning with 50.6 grams of copper and 42.2 grams of sulfur, I found out that this would be the limiting reagent, and this is how much product I would form based on the moles of the copper that were going to be my limiting reagent, comparing it to the mole ratio of copper to copper 1 sulfide, and then converted that into grams so I can find the gram amount, okay? It's kind of tricky in the beginning, but as you start to roll through it, it really starts to make sense as you work on the practice problems, okay? Thanks for watching.